Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with numbers 9 and 10 in your Unit 1 homework. So there's a pair of vectors in this picture, A and B. They are not yet tip to tail. Now you don't necessarily have to draw them tip to tail to do these vector additions, but let me just talk about what that would look like if we did. To get these tip to tail, you either move B over to A or A over to B. If I move B over, that means you're taking this and you're putting it here. So that would look like this. Then you would sketch your resultant. Now notice I also could have taken A and moved it to the end of B. And that would have looked like this. There's vector A. And the resultant ends up at the same point to within my little, that's just a little bit of error because I did this quickly by hand. This method, again, is called the Parallelogram Method because if you do both of them, you kind of make a parallelogram here. You don't necessarily need to do that much for these problems. This one doesn't actually say to sketch it, so I talk about how to do what this thing says. Let's see, find the resultant vector, express it in unit vector form. So what you want to do is this. Start by writing vector A in unit vector form. It's going to look like some number I plus some number j. And the way you get those. If you need to, draw the components. Vector A has an x component that looks like this, y component that looks like this. And if I were working this, I would call this ax and ay. And then use the right triangle trigonometry, because this is a right angle to find ax and ay. Those will both be positive numbers. Those numbers go here and here. You can do the same thing for vector B. Now I don't want to do this for you, but if I were going to do this, I would use a different color at least, but draw the components of B. You notice they're right and down. Use right angle trigonometry to find those components. And write B out in unit vector form. Now, my recommendation is don't worry about the plus and minus signs till last. Just do your triangle, find the distances, the horizontal and vertical distances, and just put in signs by observation here. B has a positive x component because it's to the right, so that's going to be a positive number. But it has a negative y component because overall B is pointing down in a quadrant 4. So you will have a minus sign. Insert a minus sign right there for that effect. Then what you do is just add them vectorially. That means you add them by components. You're adding these together and these together. Then you can write out your resultant. It will be equal to something I plus something j. Now, when it says express in unit vector form, that's what I mean. So your answer will be some number I plus some number j. Just by inspecting the picture, I'm positive this will be a positive number. This one I don't really know right off the top of my head. Probably going to be negative, but I'm not going to worry about whether it's plus or minus. I'll let you sort that out. To do the rest of this, where it says unit vector form, that's done. Magnitude direction. Once you have these, use them to sketch your resultant. And then apply a Pythagorean theorem. That'll get you the magnitude. And the tangent function should get you an angle with respect to the positive x-axis. Number 10 here. The diagram for this is done very nicely for you. Take each of these vectors and draw their components out. So for example, vector A has an x component to the right, y component up, and then label them. I would call them like ax, ay. Use the right angle trigonometry to find ax and ay, and then write vector A in unit vector form. So A is going to look like a number I plus a number j. Repeat for vectors B and C. Now B is basically to the right and down, so B will have a positive x component but a negative y component. C, and I'll just say this for C. Notice it doesn't go up or down. So think about what does that mean for its y component, and basically the x component's given. There's really no calculations to do for vector C. Once you get those vectors written in unit vector form, just add the components up. You'll have the resultant vector in unit vector form. That should get you through those problems. Hope that this helps. Have a great day.